Hello everyone, welcome back. We did location planning in the last section. What did we do? Like I said, we had a forecast on us. After we realized how many units are we planning to produce, we had to decide on a location to produce these units. Once we decided on a location to produce these units, now the next step is on that location. So if it is, let's say, a 10,000 square feet area, or let's say the MIDC has given plots. So plots of standard sizes, which is everybody gets a 5,000 square feet plot. So if everybody gets a 5,000 square feet plot, you want bigger, so you buy two 5,000 square feet, you get a 10,000 square feet plot. Once I have a 10,000 square feet plot, now the question at hand is, how do I set up my facility in this plot? So we are going to do something called as facility planning. What is going to happen in facility planning? We are now going to plan a facility. Now, what do you mean by facility planning? So if you've ever gone to a production plant, or if you've gone to these industrial buildings in Bombay for that matter, what you will see is that there are a lot of rooms and all the rooms are the same size. There is no size variation in the rooms. Everybody gets a standard room and then you do whatever you do with it. So then people put partitions and create different rooms. And that is why these rooms are standard rooms where you decide what to do. Now, how does it matter what to do? So let me give you or show you the example that we are going to do and then move ahead, so that explaining things will become slightly easier. Facility planning. This is your module question, my question 1, module question 30 on page 9. The present layout shown in the figure, the manager of the department is intending to interchange department C and F in the present layout. The handling frequencies between the departments is given. All the departments are of the same configuration, size and configuration. The material handling costs per unit, length travel between the departments is the same. What will be the effect of interchange of departments C and F on the layout? So now that you've read the question, let me tell you what it means. So this is a layout of your plant. How are the departments? Well, you decide. Suppose your organization has 6 departments. Let me list the 6 departments. Well, department number 1 is manager's cabin. Department number 2 is washrooms. Very important. Department number 3, production. So where production takes place. Let's say I have 2 production departments. So there is another production 2. So this is P1, this is P2. Department number 5, finance, where all the billing in and out happens. And lastly, department number 6 is recreational area or rest area. Well, let's say there is a couch with a TV or a bed, if at all anybody is unwell or wants to take a quick nap, anything like that, there is an area. So manager is M, washroom is W, production area P1, production area P2, finance and rest. Now you decide that if this is your entire unit, this unit is divided into 6 equal parts. Very important. Then who goes where? Sir, how does it matter who goes where? Put anybody anywhere, who cares? No, it matters. What happens is, suppose you put production 1 here and production 2 here, and you put the washrooms here. The manager is here. So let me draw that. Production 1, production 2, manager is here and the washrooms are here. Every time somebody in the production plant wants to go use the washroom, they will have to go from this to the manager's room, from the manager's room to the last room and then the washroom. From here, they will have to go to the washroom like this. What if you would have put the washroom here only? Lesser travel? Arey sir, but why does it matter? Well, it does. Because lesser the travel, lesser the time required to waste. And lesser time waste is more productivity. Well, there is a rest area also. Not everybody goes to rest every day. It's an area for that special day when somebody is unwell or wants to take a nap or anything like that. So can I put rest here? Yes, put rest there. That should not be a problem. Fine then. Manager will go here, washroom will go here. So this washroom I can cancel. So remove that washroom. So this is the restroom. Now the last department left is finance. Well, this looks like a good idea. Why? See, the manager has to overlook the finance as well as production. So the manager is close to production and is close to finance also. If you would put the manager here, he would be close to finance. But he or she would be far away from production. What about the washrooms? Well, the washroom is in the center, so everybody has access to them. Nobody has to travel too far. Good layout. How are you going to decide whether which department goes where? Well, that we are going to decide with a very small understanding. Whoever has to go wherever more has to be closer. Like for example, why didn't I put finance here? Because people from the production plant that are my workers, like my bottom layer tier workers, don't have to go and meet the finance manager. Neither does the finance manager have to come and meet them. Then what's the point of finance being close to the production plant? Who goes and talks to the finance people? The manager. Then put the manager closer. Then couldn't I put the manager here? Yes. But if you put the manager here, he will be far away from the production people. So I put him here. Because in a day, he has to go to both places. He has to keep visiting the finance as well as the production plant. And that is how you decide whether a given layout is a good layout or a bad layout. What is important is how many departments are connected and how many departments are required too much frequent travel. The more frequent travel that is required, those departments are close by. I'll give you a very small example and this everybody will understand. In your house or in any house that you see, there are rooms. If it is a big house, there are most of the rooms that have their own washroom. But then there is that one washroom that is put in the hallway in between, which is of same distance from every other room as well as the kitchen as well as the hall room. Why? Because it is that central location where anybody who wants to use the washroom can go. What are you doing? You are minimizing the distance from the washroom to every other room. Initially, facility planning, or even now, is done by a method called craft. What is craft? Craft is computerized reallocation of facilities technique. What is craft? Computerized reallocation of facilities technique. So what you do is in your computer program, they will give you a base layout and then you tell them what departments are and you tell them which department to which department we have to go a lot. And then they will quickly work a computer program and tell you what is the best layout so that the inter-department travel is minimized at the best. Let's come back to the question that they have given us. The question says, A present layout is shown in the figure. So a present layout is given to you. What does the present layout look like? Well, in the present layout, 6 departments A, B, C, D, E and F. Correct? These 6 departments are laid out and they are laid out in their own logic or their own technique, whatever that is. What do you want me to do? The manager of the department is intending to interchange the department C and F. So what is he planning to do? Shift C and take it to F and shift F and take it to C. So F will come here and C will come here. The handling frequencies between the departments are given. I'll tell you what handling frequencies mean. All the departments are of the same size and configuration. So if department A to B is, let's say, 10 meters, then B to C will also be 10 meters. The material handling cost, unit length travel between the departments is the same. What does that mean? Same. Like if department A to B requires 10 minutes, then B to C will also take 10 minutes. So 10 minutes, imagine if a worker is crossing 3 departments. So 5, 10, 10, 10, 30 minutes. 30 minutes into cost. Sir, what kind of department requires 30 minutes? Do you know Google's server rooms? Google server rooms are the size of football field. So this when on paper looks like 6 departments, looks very good. What is the problem here? Travel, no. Array, but do you understand if there are 6 football fields put this way? And then I am a technical team person who has to go from server room A to server room E. Imagine 3 football fields I have to cross. Imagine the time that will take. And that is why allocating of departments is very important. When I talk about a small, like I'll tell you when I was doing this, when I was doing statistics in my SY, we had to do projects. So in my project, we had done a project on a poultry, but not a chicken poultry, an egg poultry. So basically a layer is what it's called. So there, the chicken are bred not to sell for chicken, but the chicken lay eggs and then the eggs are sold. Do you know how big these poultries are? These poultries are put in 1 acre fields because you can't have a poultry square. A poultry has to be long. It has to be in the east-west direction so that no sun directly hits it. So if the poultry is like this, the sun rises here and sets here. You can't put a poultry like this because if the sun rises here, this side of the chicken will constantly get the sun through the day. And then when it comes here, this side of the chicken will get constant sun through the day. So you're not allowed to do that. That is why you lay it like this. When you lay it like this, the sun goes from east to west. So no part of the poultry gets direct sunlight for too long. So there are a lot of things. So imagine when there are 5 poultries and they are 1 acre long. Imagine walking. I think in my 20-day project only, I must have lost at least 7 to 8 kgs. It's madness walking. And that is why planning a layout is very, very important. So the manager of the 3 poultries will make sure that he's at that central location or his office is at that central location where all the poultries are equidistant. And the material handling in that. What do you mean by material handling? Look, when eggs have to go from one poultry to another, imagine eggs, a very fragile object. You drop, it breaks, loss. And there's a very good saying in production planning, and that is, no handling is best handling. Try and make sure that I have to handle the final product very little. Because the less I handle it, the less chances of I breaking it. And that is why if I have to transport eggs from one place to another, where will the truck come to pick up these eggs? Well, make sure the truck is at a central location where all the poultries can come and deliver at that point in time in the less distance. Because more the distance, more the chances of somebody dropping a tray, and somebody drops a tray, loss. And that is why the distance should be the least. What do you want me to do? You want me to interchange C and F and tell me what the effect will interchange of C and F have. Now they said something like the inter-department, the handling frequencies between the departments are given. What do you mean by handling frequencies? Well, I'll tell you. What it means by handling frequencies is that department A to F, A to F. What do you mean by to and from? Or let me do one thing. Let me draw this in my book and then I will show it to you. So this is what they have given us. So they will give you two things. Number one, the layout. What is the layout? The current layout is AB, CD, E, F. Now because I want to show you everything on one page, that is why I have drawn it like this. You can draw it one below the other. So the original layout, or you can give this a name as present layout. Okay, and this is the interdepartmental frequencies. I am only writing frequencies. But sir, what does this mean? I'll tell you. From to department A to department F, department A to department F. Frequencies means how many times do you go from one department to another. While A to A, I never go. That is stupid. Have you ever gone into a bus and told the conductor, if you get into the bus at, let's say, a station A, do you get into the same bus and tell the conductor, oh, give me a ticket to A? The conductor will be like, you are already in A, get out of my bus. So I never go from A to A because I'm already in A. A to B, I don't have to go. So let's imagine that A and B are, A is my finance department and B is the production department. Finance never goes to production. Finance goes to manager. Finance has nothing to do with production. And that is why from A to B, I never go. A to C, I require to go 90 times. Let's say A is M and C is production plant 2. On a given day, I have to go from M, which is the manager's room, to the production plant in a total of how many times? A total of 90 times. So I hope you understood this. A to D, I go 160 times. A to E, I go 50 times. A to F, I go 0 times. I don't have to go rather. B to A, why is B to A not written? Why is all this already a dash? I'll tell you something. If you go from A to C 90 times, so in a day, I go from my house to somebody else's house 90 times. Then I come back also, no? If I'm going 90 times, I will come back 90 times. If I tell you that this train goes from Bombay to Delhi 90 times in a month, are you going to ask me how many times it comes back from Delhi to Bombay? Until unless it comes back, it doesn't go. So if it goes from Bombay to Delhi 90 times, it comes back from Delhi to Bombay 90 times. Simple. And that is why B to A is not mentioned. Because if A to B is 90, then B to A will also be 90. Sorry. If A to B is 0, B to A will also be 0. If A to C is 90, then C to A will also be 90. And that is why I will record only one side. I won't record the other. I have recorded A to B, no. Then B to A recording is not required. A to C is recorded, then C to A is not required. A to D is recorded, then D to A is not required because it will be the same. So everybody understands what it means by frequencies. How frequently do you go from one department to another? Now if you notice A to D you go 160 times. Look at A and look at D. If from A to D I have to go 160 times, shouldn't D be closer to A? Why? Because remember I gave you the football field example or the poultry example. If one poultry is 1 acre, now 1 acre straight will be let's say at least a minimum of 50 meters for sure. So imagine crossing two departments, 50, 100 meters. I will have to walk 100 meters. But if it was right next to me, I would travel in half the time. Fine, that is not my problem for the time being. What do you want me to do? Well, the manager is saying interchange department C and F, and that interchange will actually be better is what he is saying. Well, I will say 1 minute. I can't interchange the departments and then realize, oh, time is being wasted now. So let's go back to the original plan. I'm not going to do that. I'm going to mathematically find out what is the current cost. Now, when I say cost doesn't literally mean cost. Cost could mean time also. Because more the time, more time wasted, more money lost. So it's cost eventually. Cost could also be distance traveled. Because more the distance traveled, more the time wasted and more the money wasted. So I am going to find out what is the current cost for traveling. And then I am going to find out what is going to be the interchanged cost of traveling. How am I going to do that? They have given me the interdepartmental frequencies. Now remember one thing. Your room or your office is on the first floor and there is a washroom also on the first floor. Now if you go to the washroom, let's say 4 times in a day, just because I shift the washroom to the next floor, does that mean you stop going to the washroom? No. So no matter where you put the departments, these frequencies will always remain the same. If my manager has to go to the production site 90 times in a day, no matter where you put the site, he has to go there 90 times a day. He doesn't have a choice. So what I am going to find out is, this is how many times do you have to go? I am going to find out what the distance of that travel is. What do you mean? If you notice, A to C is just one department on the side. Is that correct? So if this was 10 meters, A to C, this distance was 10 meters, or let's say this distance was 1 kilometer. A has to travel a total of 90 kilometers in that set time because he has to go to C 90 times. But when you look at D, how will A reach D? Well, A will have to go to C and from C A will have to go to D, or A will have to go to B and from B A will have to go to D. Either way, it has to cross 2 departments. 2 departments means 2 kilometers as it is. 2 kilometer into 160 times is 320 kilometers. Do you realize how much travel this is? So it's just not the number of times that matters. The distance between the departments also matter. And how are we going to find the distance? The distance we are going to find, and this is what we used to call it when I was studying this. We used to call it the hop cost. What do you mean by hop cost? See, they haven't told you what is the distance between the departments. But they've told you that the distance between 2 departments is the same. So if A to C is 10 meters, then A to B is also 10 meters. Then C to E is also 10 meters. If A to C is 10 kilometers, then C to E is also 10 kilometers. Now see, then I don't mind if they are scaling up and scaling down in the same pattern, then I'm just going to say A to C is 1 unit. C to E is 1 unit. B to D is 1 unit. Or in other words, I hope, girl or boy, when we were kids, we've all played hopscotch, where you draw boxes on the ground, you throw a stone, and then you hop through it and pick up the stone and come back. It's called hopscotch. Langdi, or that is what we used to call it. That is what we are going to do. I'm going to hop from one department to another to find out how many hops does it take for me to go from one department to another. But before I do that, you know what I'm going to do? A to A I won't go, B to B I won't go, C to C I won't go, D to D I won't go, E to E I won't go, and F to F I won't go. Why? I'm already in the department. Where do you want me to hop and go anywhere else? I'm already there. And then everything below this triangle will be covered by everything above this triangle, and that is why we are only going to consider the upper matrix. If you remember, if you've done mathematics in the 11th and the 12th standard, you did something called as you did a chapter called matrices, in which you did an upper triangular matrix. So this is going to be an upper triangular matrix. Fine, let's start hopping. A to B. This is where A is. Now from A, if I have to go to B, I have to take one hop. In single hop, I am in B. Fantastic. So A to B is one hop. What about A to C? Well, A to C is also a single hop away. I am in A. take one hop and you are in C. One hop. What about A to D? So, from A to D, I can do this. Start with A, go to C, go to E, go to F, and then come to D. So, how many hops? 1, 2, 3, 4 hops. What? Yeah, this is what we did in school, no? During a period, if you want to go to this is not in the recess, or this is not before or after school. When there's a legitimate period going on in class, like mathematics or something, and then you wanted to skip it. So what do? You go to the washroom, but then going from to the washroom is not straight. Then you go to, and even if there is a washroom on your floor, you go to the next floor. And then if somebody asks, you tell them, oh, they are cleaning there. This doesn't work that way. You can't take a tour of the entire facility and come back. You have to travel in the least number of hops. I agree, if you want to go to department D, you can go from A to C, C to E, E to F, and then come to D. But why would you do that? Am I paying you to take a trip around the department? No. But then, sir, if I want to go from A to D, why not directly jump from A to D? Who is this architect that has made a door in between two departments like this? Diagonal traveling is not allowed. You can only lateral travel, horizontal or vertical. So if you want to go from A to D, you will go from A to C, C to E. No. A to C, C to D is done, no. So from A to C is one hop, From A to C is one hop, and from C to D is two hops. So A to D can be covered in two hops. What about A to E? Well, A to E can be one hop, two hops. So A to E is also two hops. What about A to F? Well, A to F can be done by one hop, two hop, three hops. Or start from A, one hop, two hop, three hops. Well, from anywhere you come, you are finishing it in three hops. So we used to call this a hop cost or a hop count. How many hops do you require? Some people call it the distance, or your institute material calls it the distance. So that's fine. Frequencies are given. I'm finding the distances. A is done. Let's come to B. B to A is done. A to B is 1. So B to A is also 1. B to C. So this is B to C will be 1, 2 or 1, 2. 2 hops. What is B to D? B to D is just one hop away. What is B to E? B to E is 1, 2, 3 hops or 1, 2, 3 hops. Fine. B to F is 1, 2, 2 hops. C. C to D. C to D is 1 hop away. C to E. C to E is 1 hop away. C to F. C to F is 1, 2 or 1, 2. 2 hops away. D. D to F, just 1 hop. D to E is 1, 2 hops. D to F is just 1 hop. What about E? Well, now only one thing left is E to F. E to F is a single hop away. Done. Now what does this mean? What it means is that I have to go from A to C 90 times in a day. And the distance is 1 unit. So what is the total distance covered? 90 units. But from A to D I have to go 160 times and the distance is 2 units. So the total distance traveled is 160 into 2, which is 320 units. And this is where we now come to a matrix called as a load matrix. Now, whatever I am writing is for your understanding. You will stick to the presentation that I have given you in the material. Load matrix. Some people call it a total cost matrix. Whatever you want to call it. How do you calculate this? Let me unzoom a little because I will require you to pick up both. How do you calculate this? See, again the same. A to A, B to B, C to C, D to D, E to E, F to F, not happening. Everything below and above, not happening. Sorry, everything below that will be covered by everything above that. Fine. A to B, I travel 0 times. Okay. What is the distance? The distance is 1. So then what is the total distance for me to travel from A to B? I don't care if the distance is 1 or 2. I don't go to B. Then 1 into 0 will be 0. A to C, I have to go 90 times. 90. If A to C, I have to go 90 times. A to C, the frequency is 1. Sorry, 90. And the distance is 1. So the total distance is 90 into 1, which is 90. A to D, 160 times. The distance from A to D is 2. So I get 160 into 2, which is 320. I hope you've understood how to fill this up. So now I'm going to quickly fill this up without saying too many things. 50 into 2 is 100. 0 into 3 is 0. 70 into 2 is 140. 0 into 1 is 0. 100 into 3 is 300. 130 into 2 is 260. Then 20 into 1 is 20. 0 into 1 is 0. 0 into 1 is 0 into 2 doesn't matter anyway, but 0 into 2 is 0. 180 into 2 is 18 2s are 36, 320, 360. 10 into 1 is 10, and lastly 40 into 1 is 40. Correct? Now take a total. How do you take a total? Well, either take it horizontally or vertically, it is up to you. All you have to do is add the total distance traveled or the total cost of traveling. So horizontally, if I do that, it's going to be 90 plus 320 plus 100 is 520. Then 140, 300, 260. 140, 300, 260 is 700, 20, 370, 40 and 0. Calculate the total. 700 plus 520 plus 20 plus 370 plus 40 is 1650. So the total cost of traveling is 1650 units. Let's quickly check what they have in the solution and then let's continue. So the first matrix that is given to you here is the load matrix given by them, or the frequency matrix. The first matrix given to you here is the load matrix or the frequency matrix. Then I have calculated something called as a distance matrix for the present layout. After that, I combined the two and I created a load into distance. And then I took a total, and the total worked out to be, I think I made a mistake somewhere. Yes, this is 510, sorry. So this will be 1640, 1640, and the total works out to be 1640 units is the total. So they've taken a vertical and a horizontal total. Either way, like I said, I want a total. Correct? And this is where the first part of the question comes to an end. This is the cost to travel according to the first layout. What are we going to do next? Well, we are going to do what they are asking us to do. They are asking you to change department C and F. 1 minute. If you change department C and F, the number of times where I go from one department to another is not going to change. But the distances will change. Yes, they definitely will. So what we are going to do now is, we are going to find a new hop cost for the revised matrix or the changed layout. Now, if the distances change, the cost will change. If the changed cost is lesser than 1640, good idea. If it is more than 1640, bad idea. Don't change the departments. Fine then. let me come to the second part of the question. What I am going to do is, I am going to write down that I am revising the old layout. Or I can also say that I am changing the old layout. How are you changing? Well, department C is going to become department F and department F is going to become department C. Fine then. Let me quickly draw the revised matrix. So A and B don't change. C becomes F, F becomes C, E and D remain the same. This is my changed layout or my revised layout. Now, if you revise a certain layout, then the distance of travel might change. But the number of times you travel from one department to another, well, that never ever changes. Fine then, let me find the new hop cost for the revised matrix. So let me get the table ready quickly. Now, if you have changed the departments, I will have to keep going there. It just might happen that the distances might change. So let me now check the distance for the revised matrix. So this is going to be the distance matrix. For what? For the revised layout. Again the same. A, B, C, D, E, F. A, B, C, D, E, F. From and to. I have drawn a smaller table. Like I said, I have to fit everything. You please write down entire from to. Now again, A to A, B to B, C to C, D to D, E to E, F to F will not happen. And then the lower frequencies will be covered up by the higher frequencies, so it doesn't matter. Let's start. A to C. A to C now is 1, 2, 3 hops away. Sorry, A to B is still 1 hop away. What about A to D? A to D will be either 1, 2 or 1, 2. 2 hops away. A to E, 1, 2. A to F, 1. B to A is done. B to B I won't go. B to C, 1, 2. 2 hops away. B to D, 1 hop away. B to E will be 1, 2, 3 hops away. B to F will be 1, 2 or 1, 2. Either way, 2 hops away. C to D, 1 hop. C to E, 1 hop. C to F, 1, 2, 2 hops. D to E. D to E will be 1, 2, 2 hops. D to F will be 1 hop. E to F will be 1 hop. This is the revised hop cost or the revised distance layout. Now, like I told you, see, no matter how much the distances change, if I have to go, I have to go. The number of times I go will not change. And that is where we again come to the same frequency matrix that was given to us initially in the question. Because like I said, no matter how close or how far away the department is, the number of times that I have to go from one place to another never changes. So we are again going to find, let me place this properly. Yes, we are now going to find the total cost by multiplying the frequencies with the distance. But again the same, A, B, C, D, E, F, just that there will be a total here, and A, B, C, D, E and F, and there will be a total here. Again, A to A won't go, B to B, C to C, D to D, E to E, F to F. Sorry, will not happen. All the lower will be covered by the upper. Let's begin then. A to B. is 1 into 0, which is 0. Then 3 into 90 is 270. Then 2 into 160 is 320. Then 2 into 50 is 100. And then f into 0 into 1 is 0. Then you have 2 into 70 is 140. Then you have 1 into 0 is 0. 3 into 100 is 300. And 2 into 2 is 130 is 260. Then you have 1 into 20, which is 1. And then 0, 0, so doesn't matter. Then you have 2 into 180 is 360. And 1 into 10 is 10. And then there is 1 into 40, which is 40. Let's start taking a total of the revised layout. So 270 plus 320 plus 100 is 690. Then this is 300 plus 260 plus 140 is 700. Then there is a 20. Then there is a 370. And there is a 40. This will be dash. The total will be 690 plus 700 plus 20 plus 370 plus 40 is a total of 1820. In the previous layout, the total cost of traveling worked out to be 81640, and now with the change in departments it is gone up to 1820. Is it a good idea to change the departments? No. Don't change the departments, the cost is going to increase. So your conclusion is going to be the interchange of department C and F is going to increase the total cost of transport, and that is why it is not suggested. So what do they do now? For the new revised layout, they find a new hop cost and then they multiply it with the frequencies. What you realize is that the total cost of transport comes out to be 1820. What do we then tell them? The interchange of department C and F increases the total material handling cost. Thus, it is not desirable for modification. Do not do it. Not a good idea. So let me quickly run you through the question. What do they do in these questions? What is given and what is it that you have to find? What they will do is they will give you an original layout and the handling frequencies between the different departments. What they will say is that I am changing so and so departments. You tell me, is the change a good idea or a bad idea? So I can't change and then say it's a bad idea. So I will mathematically change it and then see if it's a good idea or a bad idea. So what will you do? You are given the interdepartment frequencies. You will find the interdepartment distance, which in my terms is called the hop cost. Once you have the distance and you have the number of times you have to go, you multiply the two and you will have a total cost. Check what the total cost is. In this case, it is 1640. Now, revise the data or revise the layout as and how they are saying. They want you to change C and F. Well, then change them and revise the network. Once you've revised the network, now start finding the new distances, because the change in departments will change the distances. But see, the original traveling frequencies will remain the same. Now with the new distances multiplied with the frequencies and find a new total cost. If that total cost is less than the original, take it. More than the original, do not take it. Tell them that it is more expensive. The conclusion they have written very well in your sheet. Although the sheet, every sheet that I'm going to give you is going to have a solution, I have a humble request. Make your own notebook, make your own solution. Have your own solution in your handwriting, and anything small that I say, if you think for you is important, write it down in your own language, in English, Hindi, Marathi, Gujarati, whatever you want to understand and you want to write it on the side. Because I'm teaching you this now You are going to be writing a paper 3 months from now. If you are a June attempt, then you're going to write it 6 months from now, 8 months from now. I don't want you to come back and then say, oh, I don't even know what this is written. No matter how minute it is, write it down. Make a note of it that this is what was done. So that when your book needs to be self-explanatory. I'm not going to stand in front of you every time and answer your questions. So your book is going to be a representation of me. It should have everything written in detail so that you are not stuck anywhere. Having said that, that is the first question in facility layout. Let's move on to the next. That was question number 40. Oh, sorry. That was question number 31, if I'm right. No, 30. Let's come to question number 2, which is in your module 32, question number 10. Page 32, question number 10. A defense contractor is evaluating its machine shop's current process layout. The figure below shows the current layout and the table shows the trip matrix for the facility. Health and safety, I'm so sorry. So, from the top once again, a defense contractor is evaluating his machine shop's current process layout. The figure below shows the current layout and the table shows the trip matrix for the facility. Health and safety regulations require Department ENF to remain in the current position. Fine, then keep ENF in the current position. Where am I asking you to shift them? What do you want out of me? Fine, the current layout is given to you. It is ACD, EBF. And the current layout frequencies are given to you. So A to B 8 times, A to C 3 times, A to D I don't go, A to E I go 9 times and A to F I go 5 times. Okay. Can the layout be improved? Also evaluate using LD score. Fine. One thing at a time. What does the question say? So there is a defense contractor and he wants to improve his current layout of the plant. Okay. Now in the middle of it, he is telling me that health and safety regulations say that ENF have to be in the given positions. What do you mean by health and safety? I'll tell you. If you be to any college which is like a commerce, which is like a science college, the chemistry lab needs to be in, you can't have a closed chemistry lab. It needs to have windows and doors for ventilation. Very important. So that is a health and safety regulation. You can't have a chemistry lab in an enclosed area. It has to be in an open area. And that is health and safety regulations. So there are a few regulations put out by, like for now you see in a building, in old buildings you will not see this, but in new buildings you will see that after every 4th or 5th for 5 floors, there is something called as a refuge area, which is basically 2 houses, but they are open. They have not done anything in those 2 houses. It's like an open plot, where if at all there is a fire, now that area will not have an electric connection, will not have a water connection. If there is a fire, you come and wait in that area because there is no electric connection, there is no water connection, there are no pipes, there is nothing. There is very little chance of fire reaching there. So you come and wait in the refuge area till somebody comes and helps you. So that is a safety regulation. So what are they saying? That ENF have to be in the same place. Can the matrix be improved? Wow. Let me do one thing. Let me find the cost of the current layout and then I will discuss the rest with you. Now, to find the cost of the current layout, if you read, they have asked you to do this in an LD score. Now, in the previous question, there was nothing like an LD score that was mentioned. Was there any LD word used? No. But here they do. You know what LD score is? Remember I told you, LD is load into distance. That is what it means. Load into distance. L represents load while D represents distance. Then what are you supposed to do with the LD score? See, you are going to do whatever you did in the previous question. The only difference is that we are not going to do it in a matrix. We are going to do it in a table. Why table? I'll tell you. If you look at this, See, A to A is not going to be there. At the same time, A to D, there are no frequencies. If there are no frequencies, A to D also does not need to be there. If you look at B, B to A, B to B, B to C is not going to be there. B to E also not required. B to F is also not required. Then only for one entry B to D, why draw an entire table? So what are we going to do? We are not going to do this for the entire matrix. We are only going to do this for paths that are required. Like for example, the path A to B is required. Then I will find the distance from A to B. The path A to D is not required. Then why find the distance from A to D? The path B to C is not required. Why find the distance from B to C? Won't I, if I draw my hop cost, won't I find every distance possible? But half the distances are not required. Then why do this? Then what will you do in such a question? In such a question, step number 1 is identify what paths are important. What are the departments from where to where I go? So, A to B is required, A to C is required, A to E is required, A to F is required. Then B to D is required, C to E is required, C to F is required, then a D to F, then a E to F. There are only 8 parts that are important. Correct? Then draw only for those 8th part. No, don't draw for any other path. How? Let me get the table ready and then I'll tell you. Now, whatever you did in those 5 tables in total in the previous question, which is, see, this was the original 1, then first hop cost, then first total 3, then new hop cost and new total 5. Whatever you did in these 5 questions is going to happen in this one and only one table. What are we going to do? The first thing that we are going to write, like we used to write it as paths, but your institute material says that it is department pairs. What is this? Pairs of departments, 2 departments together. So you are traveling from one department to another. So pairs of departments. Which departments are important? Only write those down. Okay. Let me check which departments are important. So if you ask me the important departments and I start from A to A is not required, A to B is required. Okay, then department pair number 1 or path number 1 will be A to B. Path number 2, A to C. What about A to D? Not required. I'm not going from A to D. Okay, A to E required. A to F required. Then from B there is only one path is required and that is B to D. What about C? There is C to E and C to F. So C to E and C to F. Then there is a D to F. And then lastly there is a E to F. These are the only 1, 2, 3, 4, 5, 6, 7, 8, 9 paths that are important. The rest, if not considered, is okay. Now, after getting the 9 paths in, the next thing that we are going to write down is the traveling frequencies, also known as the load between the 2 departments. So this is going to be the load or the frequencies. Now this load is given to you by them only. A to B is a load of 8, or I go 8 times. A to C is 3, A to E is 9 and A to F is 5. Then B to D is 3, then C to E is 8, C to F is 9, then there is an E to F which is 3 and then there is D to F, correct, which is 3 and then there is an E to F which is also 3. I have written down the load. Once I have written down the load, the next thing we calculate is the distance for the first matrix. And now the hop cost will not be done in a matrix. We will write the hops here. How? I'll show you. So now the first 2 columns are going to be for the original layout. or the original plan or the existing plan, whatever you want to call it. So this is going to be original layout or the current layout, whatever you want to call it. Now for this current layout, I'm going to find distances. And then I'm going to do an L into D because this is L and this is D. So I'm going to do a load into distance. Let's start finding the hop costs. A to B. A to B is 1, 2. 2 hops away. A to C is 1 hop away. A to E is 1 hop away. A to F is 1, 2, 3 hops away. B to D is 1, 2, 2 hops away. C to E is 1, 2, 2 hops away. C to F is 1, 2, 2 hops away. D to F is 1 hop away. E to F is 1, 2, 2 hops away. You have the load, you have the distance. Let's find the total load, which is the load into the distance. So the load into the distance is 8 2s are 16, 3 1s are 3, 9 1s are 9, 5 3s are 15, 3 2s are 6, 8 2s are 16, 9 2s are 18, 3 1s are 3, 3 2s are 6. And I will take a total of this. The total of this will be 16 plus 3 plus 9 plus 15 plus 6 plus 16 plus 18 plus 3 plus 6 is a total of 92 units. So the load on the original layout is a total of 92 units. What we are going to do now is we are going to revise the layout and then check whether the new layout is better or the old layout is better. Okay. How do you want to revise the layout? Well, they've told you, no. They've told you that departments, E and F cannot change. Find a better layout. Arey, 1 minute. When you say departments E and F cannot change, I will tell you what that means. If departments E and F cannot change, everybody else can change. In the previous question, they were very specific. Change C and F. Then I changed C and F. Now here you have only told me what cannot change. You didn't tell me what should change. You told me what cannot change. And then after you telling me what cannot change, you are expecting me to find a better layout. Well, I'll tell you what my problem with that is. If you keep departments E and F in the same position, correct? Where was E and where was F? Well, this was E and this was F. Okay, then E and F cannot change places. Okay, done. But now there are 4 departments left, A, B, C, D, and there are 4 empty spaces. If you've done permutations and combinations, 4 departments, 4 places is 4p4, which is 4 factorial ways, which is 24 different ways. If you have not done permutation combination also, it's simple. I'll tell you. Here, this place. How many departments can you put in this place? Well, I have 4 departments. This place, any of the 4 departments can go here. Okay. Then this place has 4 options. Done. This place is filled. How many options does this have? Well, I had 4 departments, but one you put here, which means for this place I have 3 options. 3. How many for this then? Well, 2 gone, 2 left. How many for this? 1. So it is 4 into 3 into 2 into 1, which is 24 different arrangements. So you know what that means? That means find all the 24 different arrangements. Like I'll give you an example. One arrangement could be A, B, C, D. Obviously E and F will be here, that is why I am not writing it. One arrangement will be AB, DC. One arrangement will be BADC. Like this, I will have to find all 24 different arrangements. Do you even realize how taxing that will be? It's going to be very difficult to do this. I can't find 24 different layouts, then find 24 different LD scores, and after finding 24 different LD scores, then find the cost of those 24 and then compare which one is a good idea. Not that you won't get an answer. By the way, that will give you the best answer. But my problem is, I don't have the time to do this. Or in my terms, I don't have the marks to do this. If you ask it for 6 marks, itne marks. Jitna paisa, utna hi, jitna काम उतना ही पगार. तो अगर दुनिया भर का पूछोगे 6 मार्क के लिए तो मैं करने वाला हूं नहीं. So what do you do? We are going to do this question, but we are going to fight it on a slightly different level. And how are you going to fight it? Now for the next level, I pray and I hope and I want you to listen to what I am saying and pay very close attention to what I am saying. Let's begin. For deciding which department is good and which is not good, the first thing that you need to have in front of you is the original load matrix. Once you have the original load matrix, this load matrix will help you decide everything. All you have to do is pay attention to this load matrix. Let's begin. So I have my rough patch ready. What are we going to do? They have said that department E and F have to be in the same position. Make this better. Put anything anywhere. There is no hard and fast. They have not told you anything else. They've only told you E and F cannot change places. Put anything anywhere you want. Make a better network and make a better layout and give me. Okay. So you need two things. Number one is your frequency table. Why frequency table? To make a better layout, I'm going to try and keep departments that require to be together. And the second thing that I'm going to focus on is the place of E and F. So this is how you are going to start. I have my rough patch ready. What did they say? E and F should not change places. Rest you put anything anywhere, I don't care. Okay. And that is going to be your most important point. So you are going to focus on two things. Number one, that E and F cannot change places. And these are the frequencies. So the more you need to go somewhere, the closer I will put you. If you don't require to go somewhere, the further away I will put you. If the manager does not require to, or the production plant employee doesn't require to go to meet the finance manager, then why put the finance and the production department together? No, put them far apart from each other. And that is exactly what we are going to do. How are we going to do this? Let's start with E and F cannot change place. You are going to focus on two very important things. And if you understand this, then it's gold. There are two places. One place which is extremely important and one place which is extremely not important. How come? If you notice, this place is just one hop away, while this place is farthest away for both. So this place is closest for both. This place is farthest away from both. So to reach this place, E has to do 1-2 hops. F also has to do 1-2 hops. So this is what you're going to do. You are going to put the most important person here and you are going to put the least important person here. How? Simple. Let's look at who is important to E and F. Well, to E and F, A is very important to both of them. Because E goes to A 9 times while F goes to A 5 times. Okay. What about B? Not important. So very important thing to remember that B is not important to both. Okay. What about C? Oh, C is also very important to both of them. And C is more important than A is. Find them. If C is the most important, put C in between both of them. So the most important place is done. let's come to the least important place. The least important place is the least important person. And who is the least important person? While B is the least important person because both of them never go to B. Two places left, which is A and D. If you look at D, D doesn't care about where E is because D never goes to E. D only goes to F. Then put D close to F. The last one department left is A. And obviously A had to be very close to E, 9 units. And that's it. That's going to be your answer. I'm going to show this to you a few more times. I'm going to quickly show you exactly the same way, and then I'm going to show you a slightly different way. E and F have to be in these two places. What did I do this time? I told you to remember two things. And that is, right next to E and F are two most important and least important places. This is the most important place because this is the closest to both of them. And this is the farthest away from both of them. So the most important goes here, the least important goes here. How do you know who's the most and the least important? Well, least important is easy because B doesn't fall in either. B doesn't go to both of them. So the least important is here. The most important could be either A or C. But between A or C, if you look, C is more important than A. And that is why C goes here. What about the rest? D doesn't care about E. D only cares about F. Then put D close to F. And then here goes A. Same thing, but now with a slightly different understanding. But I will show you that the final answer needs to be the same. You were looking at both of them together. Let's look at one at a time. So E and F. Correct? Let's look at E. For E, who is important? Well, for E, A is important and C is important. Okay. So remember, around E, there should be A and C. So A and C should be closest to E. What are the two closest places to E? Well, this is one and this is one. Both are one hop away. What about F? Well, for F also, A is important and C is important. So A and C have to go here also, and A and C have to go here also. But between A and C, who is more important to both? Well, to both, C is more important. That is why C goes here. But A is very important to E, so A goes here. D goes to only F, then put D close to F. And then the last place, D remains. I hope you understood how we revise this layout. Very simple, two very important places, and that is how I used to remember it. The most important place and the least important place according to the two of them. The most important place is the place that is closest to both. The least important place is the place that is furthest away from both. When you look at E and F, the most important is this place between them, and the least important place is this because it is far away from both of them. So here goes that department which is closest to both. Now A is close to both of them, but B is even closer because there is more frequency handling, and that is why C needs to be as close to both of them as possible. Who is the least important? Well, B, because both of them don't care about B. So I will put B further away from both of them. When you come to the last two places, you are left with A and D. What you realize is A is important to both of them. But in that also, to D, only F is important, E is not important. Then put D next to F and put A next to E. That is your revised layout. I hope you've understood this. We go back to your LD score table and we write down what your revised layout is. Well, my revised layout is E and F stay in the same place. C is equally important to both, so put them in the middle. B is neither important to E nor to F. And then D is important to F while A is important to E. And now for the revised layout or the improved layout, I will again find load and I will find load will remain the same. I will find distance and I will find L into D. New distances A to B is 1 hop away. A to C is 2 hops away. A to E is 1 hop away. A to F is 1, 2, 3 hops away. B to D is 1 hop away. C to E is 1 hop away. C to F is 1 hop away. D to F is 1 hop away. E to F is 2 hops away. Let's find the total, which is the distance into the load. The load is whatever they had originally given us. That never changes. 8 into 1 is 8. 3 into 2 is 6. 9 into 1 is 9. 5 into 3 is 15. 3 into 1 is 3. 8 into 1 is 8. 9 into 1 is 9. 3 into 1 is 3. And 3 into 2 is 6. So the total load for the improved matrix is 8 plus 6 plus 9 plus 15 plus 3 plus 8 plus 9 plus 3 plus 6 is a total of 67 units, if I'm right. So previously the load was 92 units. Now the new load is 67 units. Haven't I reduced the load on the interdepartmental handling? Then this improved matrix is definitely a good idea. Now, whatever I have done here, they have verbally written down. And that is what I want you to do also, one step at a time. Number 1, C is a department that has more interdepartmental frequencies with E as well as F. So we put C between E and F. Then we say B is a department that does not require to be close to E or F, or is not important to E or F. So we put B immediately below C. Correct? I've written both similarly. And so I can't refer both together. Anyway, then let's do it here. C is a department that is close to both of them. So step number 1 will be C is a department that is important for E and F both, because the interdepartment handling frequencies between C and E, C and F are the highest. That is why we put a C between E and F. Then B is a department that is neither important to C nor to F. So we put B right below C. A is closer to E than it is from F, and then D is closer to F than it is to E. Let's quickly read whatever they have written. So, solution. Keep the departments E and F at the current locations. From the trip matrix, C is having maximum number of trips to E and F. So C must be as close as possible to A and F. Put C between them. Place A directly to the south of E and B next to A. All the heavy traffic concerns have been accommodated. Department D is located in the remaining place. Or you can do what I told you. What you can say is that the interdepartmental handling frequencies between E and C and F are the highest. That is why we put C between them. Then B does not concern with E, does not concern with F. That is why we put B to the south of C. A's departmental frequency handling with E is very high. So we put A to the south of E. and then D to the south of F. That is it. After doing that, we draw the new matrix, improved matrix, we find the load into distance, we do all of that, and then finally we say, as the LD score of the proposed layout is lower than the existing one, there is an improvement in the new layout, or in other words, the new layout is a good idea. That is it. With that, only 2 questions in your module. With that, location planning was done in the previous session, and now facility planning is also done. Only 3 questions. Please practice them as much as you can. Let's come to analyzing question papers. Now, I don't want to waste too much time. So that one question paper where a question was asked on this was the June 19 question paper. I will directly take you to the question. June 19, question 2B. And the question says, the present layout is shown in the figure. The manager of the department is intending to interchange the department C and F in the present layout. So it's like the very basic question, C and F, that's it. The handling frequencies between the departments is given. All the departments are in the same size and configuration. The material handling cost per unit length travel between the departments is the same. What is the effect of the interchange of department C and F in the layout? Now let me show you something. Question 2A is 6 marks and 2B is 10 marks. 2A, 6 plus 10 is 16. So 2A is 6 marks and 2B is 10 marks. Imagine this is what is asked for, 10 marks. So let me quickly make a note of that. The June 19 question paper. So I'm writing both together, which is location as well as facility. Indirectly, the June 19 paper, and that is 2B, 10 marks. And I'm drawing a small layout to show you what kind of a question it is, or you draw whatever you want to. One question for 10 marks. Thank you very much. With this, location planning and facility planning comes to an end. I will see you in the next session with a new